on a shore, so that means there's like water or something, I don't know. Yeah, okay. The water below, and an angle of depression. Okay, so an angle of depression is made, first let's put our guy standing up here. So, and the line of sight from the observers to the object. Okay. So let's say our object is down here. Okay, so here's my observer, and his line of sight, he's looking at the object. So his two little eyeballs on his head are looking at the object on the shore. Yeah, those are his two eyeballs, okay? And we want to come up with an angle of depression. Well, the angle of depression is made from your horizontal drawing down, okay? Down. So, our horizontal of the guy's line of sight is right here. This is the horizontal. And our angle of depression is made from that horizontal down. So this is the angle of depression. So if we're looking at a triangle, here's a right triangle. And the angle of depression is actually outside of that triangle, looking down at that top. Whoa. Okay. Let's keep going. Okay, now that we're done with the symbols, we can actually do some problems. Okay, it says the figure below is a rectangular box in which E, F, G, H, and A, B, C, D are rectangles. Okay, so E, F, G, H. Okay, so that means that bottom piece of this box is a rectangle. The top piece of this box is a rectangle. Then it says BF. BF. Where's BF? This little up and down piece is perpendicular to E, F, G, H. The bottom piece and the top piece. So it's saying BF, that up and down piece, is perpendicular to this top side and this bottom side. Okay, it says name one pair of skew lines, and I gave you the multiple choice. Okay. And I went ahead and gave you a bunch of other pictures in case we need to draw on them. So I think I'm just going to draw on this top picture. Okay, it says BC. Let's find where BC is. BC is right here. And AD. AD is right here. Okay, so to be skew lines, they have to be not on the same plane, but these look like they're on the same plane. They're on that same piece of paper that the top box, that top side makes. So those are maybe. We'll have to think about it. If we're desperate, we'll pick that, but they look like they're on the same plane. Okay, let's look at GH. GH, okay, and EF. Okay, those look like they are on the same plane. They're on the bottom piece, the bottom side of that box. So let's cross those out. Let's keep going. CG, that's up and down. And DH, up and down. Well, that looks like the left and the right side of this plane that's on the side. So that ain't it. Let's keep going. BC. BC. Where's BC? BC is this side to side. and GH. Whoa, okay. It's definitely those, BC and GH, because those are the only ones that are not on the same plane, and these two lines will never intersect. They kind of look like they will, but these are on different planes. So this top line is like 3 feet above this bottom line. So it's kind of like, yeah, they're never going to touch, but one will be below the bottom one. Okay, anyway, let's keep going to part B. It says, what is the intersection, that means what's in common, of planes EAB? Let's draw. EAB. EAB, and a plane is like a piece of paper. Okay, so here's EAB, that's one plane. And it says EFG. Okay, where's EFG? EFG. Okay, let's color that plane. And it says, what is the intersection? Well, where do these suckers cross? They touch right here at EF. So part B is going to be EF. And that's not a ray, that's a line segment. So remember, line segment, we can either write EF or EF with a little line on top of it. Yeah. Okay, let's go to part C. Part C says plane EAD. Well, let me pull out EAD. Where is D at? Oh, way over here. Okay, so that must be talking about this front plane. Remember, plane means like a side or a piece of paper. It says it's perpendicular to who? Okay, well, it's perpendicular to a lot of things. We could say that it's perpendicular to this side plane. And this side plane could be DHG. Or it could even be CGH. Or it could be perpendicular to another plane. This pinkish plane could be perpendicular to this green one that I'm shading in. And this green one would be ABC. Or a variation of those letters. What else could it be perpendicular to? It could be perpendicular to this plane on the bottom. And they could cross at that EH. But it could be perpendicular to the plane on the bottom. FGH. So, either way, part C said the plane is perpendicular to what? It's perpendicular to another side, whatever it's connected to. That makes a 90-degree angle, or a dihedral angle. So anytime we have a wall in a ceiling, that makes perpendicular 90 degrees. Okay, let's keep going to part D. It says, what is the intersection of AD? Well, let's find AD. That has two little arrows on it, so it must be the line. So here's AD, but line looks like it goes all the way across. Okay, so it says, what is the intersection of this and EFH? EFH? Okay, let's see here. So this line is going side to side forever. And then it's saying, when is it going to intersect this plane on the bottom? Well, that's like saying, if I have this calculator and I'm looking at the line on the side of it, when is it going to... No, that doesn't work. Anyway, I think you can get this. This line is not going to cross with this plane because the line is like 3 feet above it or something. So it says, what's the intersection of that line and that plane? There ain't nothing. And to write nothing, we write 0 with a slash through it. Or it's called the empty set. Okay, let's look at part E. Part E says, explain why planes BCG, let's find BCG, BCG, which plane is that? That's the, looks like the back side of the rectangle. So explain why this sucker, and DCG, where's DCG? DCG, which plane is that? It's the side looking guy. Yeah, okay, so part E says, why is this back purple side and this right green side, why are they perpendicular? They're perpendicular because there's something called from that front page, dihedral angles. The wall and the ceiling make a 90 degree angle in between two planes. So it's called dihedral. And we'll say two planes cross or intersect at 90 degree angles, something like that. Woo! Okay, let's keep going. The rest of the videos are just a bunch of homework problems with all the different symbols. Okay, let's see here. It says, what is the intersection of CD and BC? And then I copy and pasted the picture so we can draw over them. If you want to try drawing over stuff, try getting like a dry erase marker and drawing on your computer screen. It wipes off. Okay, so CD, here's CD, and BC. Okay, what is the intersection? Well, where do they touch? They touch at C, point C. Okay, let's go to part B. It says, what is the intersection of planes BCE? Let's find BCE. BCE. Which side is that? That looks like it's the right side. Okay, so there's that guy. ADE. Let me find ADE. ADE. It looks like the leftish side of that pyramid looking thing. And ABC. Whoa, what's ABC? Which part of the triangle is that? That's the bottom piece. Okay, so it's saying, where do all three of these touch? Well, they don't touch over here at BC because I'm missing the orange plane. Darn. Okay, well maybe they touch up here at E, but they don't because I'm missing the yellow guy. Okay, well maybe they touch over here at AD. Yeah, the orange and the yellow touch, but not the green. So there's no spot where the green, the orange, and the yellow all touch each other. So we're going to say none. Or the symbol for that is the 0 with the slash through it. Remember, it means empty set. Okay, let's look at part C. It says, what is the intersection of AD? And it has the arrows on it. So that means we need to draw a line through AD and put some arrows on it. Okay, AB. AB. Draw that line and put some arrows on it. So if it was talking about line segment, it would not have those little arrows on top of it. It would just have nothing like part A, or it would say CD with a line on top of it, BC with a line on top of it. But ours have arrows, so we keep drawing. Okay, so it says, what is the intersection? That's where they cross, where they touch. Where do they touch? They touch over here at point A. Alright, let's keep going. Next it says, which pair of lines are skew lines? Remember, that's where they're on a different plane or piece of the pyramid. Okay, let's see. CE is right here. Okay, and DE is right there. Those are not skew lines because if you look, they're a piece of this back plane. They're on the same plane. So those cannot be skew lines. Okay, let's keep going. AB down here. CE up here. Oh, let's see. Are these suckers on different planes? Well, this AB is on the bottom plane. This EC is the back plane. So, hey, yeah, those are on two different planes. And those two lines are never going to touch each other. I know it kind of looks like they are. But don't forget, this back line is like 5 feet behind this front line. So even though they look like they're about to cross right here, remember, this is three-dimensional. So this AB and this EC are not going to touch because this back diagonal line is set back like 5 feet. Yeah. Okay, so these are definitely not on the same plane, so that's probably the answer. Let's keep going. AD. AD is this guy. BC. BC is this guy. That's on the same plane. It's on the bottom plane. Okay, let's go to the next one. D, it says AB. That's this guy. And CD, that's the back guy. And those are on the same plane. They're on the bottom. So it must be B. Alright. It says, find a pair of distinct parallel lines. Well, we know what parallel means. It means they don't touch. Okay. Let's look. But it doesn't say anything about planes. Skew lines can not be on the same plane. But parallel, it doesn't say anything about that. So they could be on the same plane. So let's watch out. Okay, part A says AB and CE. Yeah, okay, those are not parallel. Parallel means like they're running up beside each other and they're never going to touch. These are on two different planes and they're not the same tilt. So A's out. Let's look at B. It says AD, that's this guy, and BC, that's this guy. Hey, those are totally parallel. They have the same slant, the same tilt. And they're never going to touch each other because they're going to keep going out and never touch each other. Okay, so it's probably B. Let's look at C. C says AD and AB. Those touch each other at the corner, so that's not it. The last sucker says DE. That's this up and down guy. And AB. Those are not parallel. One's going up, one's going side to side. So parallel means they have to run along each other and never cross. Okay, keep going. And so parallel, they were on the same plane. So skew is not on the same plane. Parallel can be on the same plane. Okay, let's look at this last sucker. It says, find a plane not determined by one of the triangular faces or by the base. Okay, choose the correct answer below. Okay, so AEC. Let's figure out where AEC is. A is in this left corner. E is up at the top. C is way back here. And is this on the same Okay, my bad. Does this plane, AEAC, does this plane, is it one of the triangular bases? No, because the triangular base is this bottom ABC. Okay, is this piece that I drew one of the triangular faces? Not. It cuts through diagonally. So it should be A is the answer. Let's check though. Okay, we got AEB. AEB would be, and that's the front piece. AEB, that's the front face of the triangle, so that one doesn't count. Okay, CED. CED. Okay, you can barely see it, but this CED is the back face of the triangle, so that's not it. Last one, BAD. That's the bottom face of the triangle. So we were supposed to find a plane that was not one of the faces, that means the sides, the planes on the sides, or the bottom. And we found one. It was A. Because when I drew that plane that AEC created, it wasn't one of the faces. It wasn't the left, the right, the front, the back, the bottom. It cut through the middle somehow. Okay, let's keep going. It says, use a protractor to find the measure of each angle. Okay, CAE. Well, first we trace it. C is here. A is in the middle. E is up and down. Okay, so if you start at 0, which we did because C is at 0, if we start at 0, then your answer is just wherever you land, which is the E, or 90 degrees. Okay, but if you don't start at 0, you have to do some subtraction. So why don't we look at part B? Part B says F, let's trace it, F, A, back in the middle, B. Oh, okay. This does not start at 0. This goes from, what is B? B says 30 to what does F say? 130? Okay. So to get this angle B, we have to say, well, how much did I go from 30 to 130? How many extra degrees did I go? And it's 100. Or you can subtract them, and you can say 130 minus 30 is 100. Yeah. Okay, let's look at G. It says, my bad, let's look at part C. GAB. GAB. Same thing, subtract. G is at 160. B is 30. So we say 160 minus 30, and that makes our 130 degrees. Okay, lastly, half, HAF. Let's see where H is. H is way over here at 180. AF is this 130. So we're going to subtract them. And you get 180 minus, what was the F? 130 equals 50. Yeah. So the only time you can just see an answer, write an answer, is if you start with 0 degrees. Anything else that doesn't start at 0 degrees, you have to do some subtraction. Okay, let's look at this next sucker. It says, determine how many acute angles there are. Okay, and then I copy and pasted it a couple of times to help us draw. Okay, first, acute means smaller than 90. So I have this angle. This is smaller than 90. I have this sucker. That's smaller than 90. I have this angle. That's smaller than 90. Yep, you get the point. Okay. But that's not all of my acute angles. Okay, so if we count them separately, we get 1, 2, 3, 4, 5. So I definitely have 5 from over here. But let's remember, acute angles could be less than 90. So maybe here's an acute angle, something that takes up 2 spots. Oh, what about that? Yeah, that's 1. I could have this acute angle taking up 2 chunks or 2 sections. Okay, let's see, what else could I have? I could have 2 more chunks. I could have this sucker, E, all the way over to C. Yeah, that would look like this. Try not to get too crazy. Okay. And where else could I have another acute that's only 2 chunks big? So I had the first 2, the second and the third. The third and the fourth. Yeah. This could be an acute angle too. You see that? Yeah. Okay, so how many total is over here? We have the purple, the pink, the yellow, the green. Did I leave anything off? No, I did not. Did I do these 2? Yep. 1, 2, 3, 4. Okay, so that's 4. Let's keep going. So we made up acute angles that were 1 chunk big. Then we did 2 chunk big. Now let's try 3 chunk big. So 3 slices big. So there's 1 angle. It's still acute. It has 3 little angles inside of it, but it's okay. It's still acute. It's still less than 90. Okay, so that could be 1 3 angle. Then I could have from E to D to C to B. Hey, that's another 3 angle or 3 chunker, but it's still acute. And then lastly, I could have this guy. Yeah, this could be our last acute angle. Yeah. So we counted 5. If we just count them one by one. If I include 2 at a time, I get 4. If I include 3 at a time, I get, how many was this? 3? And then let's see if I get 4 at a time. If I do 4 at a time, I have this guy. That's an acute angle because it's lower than 90. And then I also have this guy because it's lower than 90. It looks like that's just 2 options. So 1 chunk big, I have 5 acute angles. If they're 2 chunks big, I have 4. If they're 3 chunks big, I have 3. If they're 4 chunks big, I have 2. And then if I count all 5 chunks, it will not be obtuse. I mean, it will not be acute anymore. Okay, so let's add this up. 5 plus 4, 9, plus 3 is 12, plus 2 is 14 total. Yeah. Alright, let's keep going. Next sucker, it says name 3 points in the diagram that are not collinear. Collinear means on the same plane. But we want it not collinear. And, my bad, I said it's not on the same plane. Collinear means not on the same line. My bad. Coplanar is same plane. Collinear is same line. Okay, so let's see if these dots are on the same line. We got M, N, R. M, N, R. Oh, those are collinear. Okay. Let's look at MPJ. MPJ. Those are not on the same line. Because M and J is on the same line, but then P's way out there. So that one's boo-boo. And we wanted the boo-boo ones. We wanted the not collinear ones. Let's keep going. MNP. MNP. Oh, those are not on the same line. And that's the boo-boo one we wanted, because we were looking for not collinear. Then MRJ. MRJ. Those are on the same line, so we're not going to pick that. Keep going. PMR. PMR. Those are not on the same line. One of them's way out here, that P. So this is definitely one of our answer because it's not collinear. And then lastly, MNJ. MNJ. Those are the same line. So our answer is B, C, and E because those are not collinear. They're not on the same line. To be on the same line, they have to be on the same line. You can't have a dot hanging out here. Okay, let's keep going. The next sucker says, I think this is your number 1 on your homework. Determine if each of the following statements are true or false. Okay, it says, 2 intersecting lines are coplanar. So this is saying coplanar means it's one piece of paper and it says 2 intersecting lines. Let's see, if those 2 lines intersect, are they on the same plane? Heck yes, they are. They have to be on the same plane. Okay, part B says 3 non-collinear points are always coplanar. So 3 non-collinear points are always coplanar. Well, these are 3 non-linear points. I got 3 dots. They don't make up a line, and they're on the same plane. But I could also have one piece of paper with 2 dots, and then another piece of paper with a 3rd dot. Like this. These points are non-collinear because they're not on the same line. If they were on the same line, the line would be drawn already. But these are not on the same line, and heck fire, they're not on the same plane either. So, part B says they always are coplanar. False. And it's false because we could have 2 planes with dots on each piece of paper. Okay, let's look at part C. It says 2 planes can intersect in only 1 point. Well, that would be if this piece of paper or plane touched this bottom piece of paper in just one spot, then yeah, it would touch at just 1 point. But what if this plane went through the paper and cut through the paper to the other side? Then they would touch at a line. Kind of like dihedral angles. Remember a wall and a ceiling? Those are 2 planes and they're intersecting, but they're not intersecting at just 1 point. They're intersecting at a line. So part C says 2 planes can intersect in exactly 1 point. Nah, bro, it can be more than 1 point. Because it could be dihedral. So C is false. Because I could have the ceiling and the wall touch each other at a line. When they intersect, they touch each other at a line. So part C said they only crossed at 1 point, but we're saying no, it's false because they can cross at an entire line, like the seam of a wall and a ceiling. Okay, let's go to D. It says a line segment contains an infinite number of points. You might be thinking, oh, that's false because line segments only have 2. Well, technically, there's another point secretly in there. And we can put another point secretly in there. Technically, lines are made out of infinite amount of points. What? Lines are made out of a ton of points just lined up next to each other. And then they make a line. So anyway, D is false. No, my bad. What does D say? D says a line segment contains an infinite amount of points. That's true. Okay, part E says the union of 2 rays is always a line. Okay, well, a ray is a line with a dot on one end. Okay, and it says the union, that means from our very front piece of notes, it says both pieces of it. Count everything. Okay, well, it says a union of 2 rays is a line. Well, not if I combine my rays like this. I have 2 rays, and this doesn't make up one line because a line is straight, side to side, up and down. This makes 2 pieces. So the union of 2 rays is always a line? Nah. Maybe if the 2 rays were facing opposite directions, like these 2 rays, when I attach these 2, yeah, when I attach these 2, yeah, they make up a single line. But rays aren't always in this direction. They can be in all funky kinds of directions, like this example. And if they look like this example, they don't make a straight line. Yeah. Okay, let's keep going. This next one says name 2 rays that contain the following line segments. Okay, in P. Well, first let's find NP. NP. Okay, well, the ray that contains that is, we could say, N all the way to P with an arrow, as in NP with a line and an arrow on the P, because that's the part that keeps on going after the P. Or I could even say R P, because RP still contains that original basic segment of NP. So both of those rays contain NP. One of them looks like it for sure, the other one not so much. Let's look at the next sucker, SU. SU is this guy. Okay, so I could stay at the S and go longer all the way to U and further. So SU, but put an arrow on the U because that's the part that went further. Or I could go backwards and include R all the way to U. Okay, what about, could I do, what letter is this? T. Yeah, let's see. What about, could I do T U? And the answer is no, I can't, because TU doesn't include the S from the very beginning. So whatever ray I make has to include the original piece that you started with. You can either write the exact same thing with an arrow, or you could start a letter backwards with the R, but you can't start in the middle. Okay, let's look at this next sucker, protractor. It says use the protractor to find the measure of the angles. Okay, part A, it says a little m. That just means measure of, as in tell me the number. Okay, well first let's trace. C-A-B. C. Where's A? Oh, A, right there. It's in the middle. And then B. Okay, so we need to figure out how much this sucker is. Well, if we would have started at 0, wherever 0 is, up here, then maybe my answer would be just 40 from looking at the picture. But I didn't start at 0. It looks like this sucker is from 20 to... let's see, 20 to 30, 30 to 40. That maybe looks like 45. Okay, so we're going to subtract those. 40 minus 45 minus 20 is 25 degrees. Yay! Okay, let's keep going. EAC. Let's trace. E. A is in the middle. C is crazy out here. Okay, let's count how much this is. It looks a little awkward. We might have to use our brain. Okay, so it looks like we start at 50 and we go all the way to 90. Okay, how much is this chunk? Well, if we went from 50 to 90, we say 90 minus 50, and that makes 40 degrees. Yeah, but that's just this piece of a chunk. Let's find this other piece. This is kind of like two protractors are sitting on top of each other. It's kind of like this one that we did on the page before, and then there's one below, sitting below. Okay, anyway, let's see here. Let's figure out how much this other chunk is worth. It looks like it goes from 90 to... poop. That's 90 minus 45, idiot. This C isn't at 50. It's at 45. I'm such an idiot. Okay, okay, so anyway, this top chunk is 45. Let's count this bottom chunk. It's from 90 to, help me out, not 50, not 40. It's halfway in between. 45. Oh, hey. That's another 45 degrees. So all together, this whole thing, this whole orange makes up 45 plus 45, or 90. Okay, let's look at part C. DAF. Okay, find D. Here he is. A is in the middle. F is down below. Whoa. Okay, so we need to figure out D all the way around. Yeah. Okay, well, this top half is from 0 to 90. So that's definitely 90. And then the bottom half is from 0 to 90 again. So this top right is 90, the bottom right is 90. All together, that should make 180. Okay, now it says find the measure of the reflex angle of FAC. Okay, well first let me find FAC. F is, where is it? Oh, it's the bottom. Ooh. Okay, it's the bottom, F. Here's F. A is in the middle. Where's C? Okay. Let's remember what reflex is. I think we did it on the front of your notes. It says the reflex angle is over 180. It's the big angle created over 180. Okay. Well, this is not the reflex angle, because we want the angle that's obtuse. So we want this guy, this big guy, yeah. Okay, so again, the reflex angle is not this smaller angle. Reflex angles are basically the bass-ackwards, or everything except, or the complement, or go the other way. So let's figure out how much this is. Well, we just learned that the whole right side was 180 for part C. So that means that this whole left side should be 180. Plus however much this is. So we're trying to find this big angle, the obtuse. And I know this left side is for sure 180 because we just saw that on part C. But now let's add this piece. How much is this portion worth? It looks like it goes from 0 to 45. So that reflex angle is whatever this 180 plus 45 is. 225. What? Yeah, let's keep going. Okay, it says name the amount of obtuse angles. We've kind of done this before. Okay, first, these tiny little chunks are not obtuse. They have to be bigger than 90. So we know this DE is a 90. So anything with a little extra over this DE is going to be the obtuse. So I could have DOC, not DOD, or sorry, not EOD, because that's just a 90-degree angle. But I could have whatever the heck this is, which is EOC. Or I could have EOB. Or I could have EOA. Those are all obtuse. Okay. Or I could have FO, not E, because that would be an obtuse, but I could have FOD. That would be an obtuse. And let's see here. So we have all of those. 1, 2, 3. We could have that. Oh, or we could keep going. Keep fanning out left. So we could have FO, not D, but we could go FOC now. Then we could keep going. FOB, FO. So this was FOC, then I could have FOB. And then let's check FOA. FOA, uh-oh. That's just 180 degrees. So that's not obtuse. Darn. Okay, so let's see here. We should have 1, 2, 3, 6. Yeah. But not this last one, because that makes 180 degrees. Alright, let's keep going. Last one. It says, Bonnie named the line ABC. How do you respond? Well, I respond by saying lines are not written with 3 letters. Okay.
So part A says the line is named correctly. No, it's not. Part B says 2 points determine a line, so only 2 points are used in the name. Yep.
Yeah. So when we talk about lines, every time we only write 2 letters, not 3 letters. Okay. Woohoo!